During this film, you will have to take down readings from the screen. We're going to investigate the mechanism of this reaction. It's the reaction between bromine and an alkene, the gas propene. The reaction takes place in a solvent, methanol. Here's the bromine. We take some out by pipette and filler. And run it into the methanol. Now the propene is bubbled through the solution of bromine in methanol. The solution is decolorized as the bromine reacts with the alkene. We must now work up the reaction mixture to get out the product. There's water in this separating funnel. The reaction mixture is poured in. Then we add diethyl ether, ethoxyethane, which will dissolve out organic substances. The ether forms a layer on top of the water. The funnel is vigorously shaken to mix the two layers. Then we run off the bottom aqueous layer, leaving the ethereal solution in the funnel. This should contain the reaction product. We use dried magnesium sulfate to remove any last traces of water. After a short time, we filter the mixture. Any product from the bromine-propene reaction will now be here, dissolved in the ether. We shall use this gas-liquid chromatography machine to investigate the product. In the machine, there's a sort of oven which contains the chromatographic column. The sample comes in here as vapour at the temperature of the oven. The column is coiled into a spiral to save space. It's filled with these inert granules. They've been coated with an inert liquid. Vapours have different solubilities in this liquid. A carrier gas coming in through a pipe here mixes with the sample and carries it round the coil. The carrier gas is nitrogen from this cylinder. If we put the coil back in the oven, we can now look at its other end, where the individual components emerge after being separated in the coil. They come out at this detector, which is fed with hydrogen from this cylinder and air from this one. The hydrogen is burnt at the detector. You can't see the flame, but if we hold a cold glass surface over it, there's the condensation from the burning hydrogen. Now, when a vapour has travelled right through the spiral and reaches this flame, it will change the flame's electrical properties. We inject the sample here. It's vaporized inside the oven and passes through the column. This is the syringe we use to inject the sample. It's graduated in microliters. The drop is 5 microlitres, pretty small, but we'll be using even less in the actual experimental runs. So, that's where we put in the liquid we're investigating. The boxes contain circuits to detect electrical changes in the flame. The results are fed across to a paper trace recorder. At the moment, the pen is stationary, just tracing out a straight line as the paper comes slowly out, indicating the passage of time. Now, our sample from the propene bromination is a solution in diethyl ether. So first of all, let's run the pure ether through the machine to find out what happens. We inject 0.5 microlitres of ether, a tiny quantity. Inside the oven, that ether will be almost immediately vaporized and it will pass into the chromatographic column. As we injected the sample, we made a kick on the paper trace to show the time at which the experiment was started. You can see it there on the paper. Now, as time passes, the ether vapor is being swept through the spiral column by a stream of nitrogen, and it will take a certain time, depending on its solubility in the liquid inside the column, to reach the hydrogen air flame at the detector. When the ether vapor reaches the flame, we should see some indication on the paper trace. Watch. There, a big deflection, showing that the ether has got to the detector at the end of the column. Now we can stop the recorder and remove the paper trace. You must be ready to take down a reading from the trace. We lay a transparent graticule on top of the trace and line it up so that we can measure the time it took for the ether vapor to pass through the column. We call this the retention time for the diethyl ether. The time is measured along the vertical axis. Here it is. 2 squares. Call it 2 units. It doesn't matter what the units are. 2 units. Ether retention time, 2 units. Write it down. Now we can run our experimental liquid through the machine, the product of the bromine-propene reaction in ether. We use the syringe again. And we inject a tiny sample into the apparatus. Once again, as we do this, we make a starting kick on the paper trace recorder. Now, both diethyl ether vapor and the vapor of the product of the propene bromination will start their journey along the chromatographic column. There's the kick on the trace. Nitrogen is carrying the vapor along towards the flame. And there's a deflection. Something has reached the flame at the top of the machine. It looks like the ether peak again, which is what we should expect since our test liquid was a solution in ether. After about 3 minutes, another peak. Some other vapor has reached the detector. This must be the product of the reaction between bromine and propene. Afterwards, you can work out what you think this substance is. Now get ready to take down some more readings. The first retention time, 2 units. This first peak must be ether again. Now for the second peak. It took longer for this vapor to reach the detector. Write down the retention time for this second peak. It's about what? Well, there's 5 units. 5, 6, 7. It's about 7.8. Estimate it. Write it down. Let's now go back to the solution of bromine in methanol we started with. We're going to add a new substance, a salt lithium chloride. Once again, we pass propene through the solution. Once again, the bromine is used up. We work up this liquid as we did before, adding water, extracting with ether, then drying the ethereal solution. And we inject a tiny sample of the solution into the chromatographic column as before. Vapours will again be produced, which will take different times to pass through the spiral column and reach the flame. There's a first peak. Once again, this is probably the ether. About 1 minute later this time, a second peak. A second vapour has reached the flame. Then, about 1.5 minutes later than that, yet a third peak. 3 substances present in the sample have passed right through the column and reached the detector. Now for a lot of readings. First, the retention time, first peak. 2 units. So that's the ether again, as we thought. Get ready to estimate the retention time for the second peak. Here it is, 5-point-something units. Estimate it, note it down. That's the retention time for the second peak, obviously something different from last time. Now for the third peak. Write down this retention time. 1, 2, 3, 4, 5, 6, 7-point-something units. We had this one last time. We can now estimate the relative quantities of the 2 substances represented by the peaks if we measure the areas they enclose. For this we'll need first their heights. So write down this, the height of the second peak. And this, the height of the third peak. And we'll need the width of the peaks at about half their height. So here's the reading for the second peak again. The breadth halfway up, about 0.8 units. Estimate it, write it down. And write down the corresponding width halfway up the third peak. About what? 0.5, 0.6 units? You estimate it, write it down. Now you can use these results to consider the possible mechanism of the reaction between bromine and propene. What happened in the presence of lithium chloride is very important. Your booklet notes tell you what to do.
Experiment Chemistry brings to an end our school's programmes for today. They begin again tomorrow morning at 9:30 with Central's programme for junior children. Stop, look, listen.
Children, always so trusting, happy, unafraid. What a pity to have to remind them about the darker side of life. Danger from going with strangers, especially strangers in cars, enticing children to get in with plausible stories.
Would you like to get in my car? Mummy sent me to fetch you.
You naughty, naughty, naughty man, I don't believe you. Take that, and that, and that.
Now then. Always remind your children about the danger from strangers, but do it in such a way as you don't frighten them. And make sure you always know where they are.
That's the way to do it.
Now, would viewers in the Breach Hill transmission area please note that this transmitter will be off the air from 0900 hours to 1600 hours, that's 4 o'clock, tomorrow, Thursday the 15th of May. And would viewers on the Ipstones Edge area please note that this transmitter will be off the air between 1300 hours and 1400 hours, that's between 1 and 2, tomorrow, Thursday the 15th of May. And also for viewers in the Oakamore area, this transmitter will be off the air between 10:30 and 11:30 tomorrow, Thursday the 15th of May. Well, now look at programmes later on Central. Starting at 12:30, Clive Gunnell continues his journey along the Cotswold Way, from Hawkesbury Upton to Wootton under Edge, via the marvellous Somerset Monument. Following the lunchtime news at 1:30, the times are changing for Amanda and Lee in Scarecrow and Mrs. King. Then the accent is on healthy eating with milk, yoghurt, cheese and cream in the farmhouse kitchen at 2:30. And at 3, Bamber Gascoigne introduces 2 final teams competing in this year's University Challenge. And then family problems continue in our afternoon serial Sons and Daughters at 3:30. That's programmes to enjoy this afternoon. Well, now a glance ahead to this evening. And Dr. Miriam Stoppard introduces a new series of the medical programme Where There's Life at 7. Then it's the big day for Mike and Susan in Coronation Street at 7:30. William Shatner and Leonard Nimoy star in tonight's midweek film Star Trek The Wrath of Khan at 8. And following the national news at 10:30, AIDS is the subject for the last programme in the series Society, Science and Sex at 10:30. Well, there's certainly a complete variety of programmes to enjoy, to inform and to entertain this Wednesday on Central.